All right. I'm going to give you the notes for section 5.5, order of operations and complex fractions. So we've already had all of our different operations, addition, subtraction, multiplication, and division. And now we're kind of putting it all in one problem. So the first one is an example of order of operations. Now remember, we've had order of operations before. We used GEMS, G-E-M-S. So there's no grouping symbols here, but there is an exponent. So the first thing we have to do is the exponent. And if you do this exponent, 1/2 squared is 1/2 times 1/2, or 1/4. Okay, now we have addition and division. Remember, in our order of operations, any multiplication or division comes before addition. So that means I have to do this problem here next. So I'm just going to use a little bit of scrap up here to do it. So I'm going to do 1/4 divided by 3/4. Let's remember, how do I divide fractions? Well, I multiply by the reciprocal. And in multiplication of fractions, you can cancel. So I can cancel the 2 4s, which means I have 1/3. So 1/4 divided by 3/4 is 1/3. So this problem down here becomes 1/4 plus now 1/3. So now I have an addition problem, so I'm going to have to go ahead and I'm going to have to find a common denominator because it's addition. The smallest number that 4 and 3 divide into evenly would be 12. So let's go ahead, let's rewrite the first fraction. What do I have to multiply the bottom by that's going to get me a 12? Well, that's going to be a 3, so I have to multiply top and bottom by 3. Let's take the second fraction, and again, what do I have to multiply top and bottom by? Well, 3 times 4 is going to make the lowest common denominator of 12. So if I multiply now, that's 3 over 12 plus 4 over 12, which gives me a grand total of 7 over 12. And you are done with that problem, but you had to finish your order, use your order of operations. All right, let's go ahead and let's do this one. So order of operations, remember this is a grouping symbol, says you get an answer for the top. Well, that's already done. And now we get an answer for the bottom. So on the bottom, we have to do our exponents first. So 3 squared is 9, minus 2 squared is 4. So we can finish off the bottom to get 9 minus 4, which is 5. So now let me remind you, this means division. So this problem is really a division problem. So let's go ahead and write it as a division problem. It would be 5 over 8 divided by 5, and let's put that over 1. Because now I have to flip the second fraction and multiply 5 over 8 times 1 over 5. I can go ahead and cancel the 5's, and my final answer there is 1/8. So that problem is also called a complex fraction. A complex fraction means you have a fraction within a fraction. If you look at C, that is also a complex fraction, a fraction within a fraction. So what we want to do is we want to do that problem, which is really a division problem. So let's write it as a division problem. 3 over x divided by 9 over x squared. Well, remember, when you divide, you flip the second fraction and you multiply. So it would look like that. Well, what can I cancel? Number-wise, I'm looking at the 3 and the 9 because 3 divides into 3 once, and 9 divided by 3 is 3. Now remember, I can also cancel these variables. There's 1x on the bottom and 2 on the top. So that means this one's going to cancel out, leaving me with 1x on the top because the higher exponent is on the top. So if we go ahead and multiply straight across, you can see 1 times x is x over 3. And that is the final answer for that problem. Now, look at this one. This is a crazy complex fraction. There are 2 methods to do this. I'm going to show you what I believe is the easiest method. The first thing that you want to do, and remember you can stop this video at any time and replay it if you need to, is you need to find the common denominator for all of the fractions. So 5, 10, 2, and 5. What's the smallest number that all of those numbers, 5, 10, 2, and 5, divide into evenly? It's 10. So what you want to do with that, and this is going to look crazy, but it's not bad, is you're going to take every fraction in the problem and you're going to multiply it by that lowest common denominator over 1. So just write it out, and I'll show you why that works. So multiply it by 10 over 1. We're going to take the bottom, same thing, 1/2 times 10 over 1 plus 3/5 times 10 over 1. So you can see each one of the original fractions is multiplied by 10 over 1. Now look what happens. When I do these 2 fractions and multiply, the 5 cancels into the 10 twice, and I simply get an 8. There's really a 1 on the bottom. Minus, when I go to do this problem over here, the 10s cancel, and all I'm left with is 7. Now it's time for the denominator. If I multiply these together, you can see that 2 cancels into the 10 5 times, and that whole thing turns into a 5, plus, if I do this one, the 5 cancels into the 10 twice, and 3 times 2 is 6. So it turns into all the big fractions turned into just regular integers. So now if I just finish off the top, 8 minus 7 is 1, and 5 plus 6 is 11. And there you go. Okay, so really take good notes on that. Back it up if you need to make sure that you get all those steps. All right, our last problem here is a story problem. Let's go ahead. You have it with you. Justin knows that there are approximately 4.5 kilometers and 3 miles. If he has to drive 7 miles to reach his destination, approximately what distance will he travel in kilometers? So this is actually a proportion problem. Remember we did proportions earlier? So what's my first proportion? It would be 4.5 is to 3, because this is kilometers and this is miles. So 4.5 kilometers goes with 3 miles is equal to, now it says he must drive 7 miles. So is that going to go on the top or the bottom? That's going to go on the bottom. And then on the top is going to be our x. So kilometers to miles equals kilometers to miles. And we're looking for the number of kilometers. So we've done these problems before. The only difference is now you're going to have a fraction to deal with. All right, I'm just moving my paper. So here we go. We're going to cross multiply. If I go this way and cross multiply, I'm going to get 3 times x is equal to, if I cross multiply this way, I'm going to get 4.5 times 7. So we don't do this section because they expect you to remember how to do it from other classes, but if I'm going to multiply these 2 numbers together, I have to change this to an improper fraction. 2 times 4 is 8, plus 1 is 9, so that's 9 over 2 times 7 over 1, because I need to multiply. Is there anything that cancels over here? I don't see anything. So if I multiply straight across, I'm going to get 63 over 2. So now I have to get the x alone. What's happening here? These 2 things are being multiplied, so we have to divide both sides by 3. These 3's are going to cancel. This is a complex fraction. So remember, what is a complex fraction? It's really a division problem. So it's 63 over 2 divided by 3 over 1, which is simply 63 over 2 times, flip the second guy. Whoops, my paper's moving. 1 over 3. Now, we can cancel. 3 does go into 63. 3 goes into 3 once, and 3 goes into 63 21 times. So the answer to that problem is, 21 over 2. 21 over 2 what? If you reread the problem, we were looking for a number of kilometers. So it'd be 21 over 2 kilometers. And that would be the answer to the story problem. And there you go.